Okay, we want to talk about box plots. First question that arose in class. So what is a box plot? Well, everybody, at least people who've been doing their work, seem to know the definition. You have a box, and the left end of the box represents the first quartile, the right the third quartile, and there's a line through the middle of the box that represents your median, which is, of course, your second quartile. And then you have a tail that goes over to the lowest on this end and a tail that goes over to the highest result on this end. And we illustrated that with one of the problems on the test, on the practice test. We had numbers, lowest was 6, highest was 15. So we already know what's going to go here and what's going to go here. We put the numbers in order and then we determine the median. How do you determine the median? The median is the number right in the middle. Now somebody wanted to say, well, the 11th number, well, that would be this one, is right in the middle. Well, there are 20 numbers in this list. Okay, so on this side of the 11th number there are 10 numbers, but on this side of the 11th number there are only 9 numbers, so that number isn't right in the middle. What's right in the middle is the middle between the 10th and 11th number. The middle is here. This point splits the distribution into 10 numbers up here and 10 numbers down here. And the median is therefore in between the 10th and 11th numbers, as you can easily determine, because if you go halfway between the 10th and the 11th number, there are 10 numbers up to that point and 10 numbers after that point. Okay, so the median would be the average of these two numbers. Now, in this case, the two numbers are both 11. The average of two 11s is 11. Your median is 11. But I've written down the process. The median is the average of the two numbers. The two numbers are both 11, so the median is 11. Okay, well, there are a lot of repeated numbers, and it turns out every time you average to get a median, you're just averaging the same number twice, but that doesn't always occur. Obviously, if all these numbers are different, you would have to average two different numbers here, and you get the number halfway between them. Well, okay, now what's the first quartile? Okay, the median is defined to be your second quartile. And of course, I think everybody should know that, having done the homework. But we'll call this Q2. Okay, so here's our median. Now this isn't the box plot for this distribution. We've actually drawn a box plot for this distribution, and we'll get to it. The first quartile is what? It's the median of all the numbers that are less than the median. Okay? Well, I've circled all the numbers on the low side of the median, all the numbers that are less than the median, and there's a little bit of confusion about low side, okay? Because the low side looks like it'd be down here. Well, when I say the low side, I mean the numbers that are less than the median. And since we usually list our numbers from lowest to highest, the low side is the side that's on this side of the median. Anyhow, it's the numbers lower than the median, okay? So I'm going to just clarify a little more. By low side, I mean the median of all the numbers that are less than the median. So there are 10 numbers less than the median. Well, that means that we're going to go down between the 5th and 6th number, because that's where you have an equal number on this side and an equal number on this side among the numbers that are less than the median. Okay? Now there's a formula for that, and if you want to incorporate the formula, okay, but you still always kind of need to check yourself and make sure that you have as many numbers on one side of the median as the other. Well, numbers on both sides of this median are both 9, so you're going to average the two 9s and you're going to get 9. So your first quartile is 9. And then you use the same idea for your second quartile. You go the numbers that are bigger than the median, the numbers on this side of the median, this half of your distribution, and you find the number that's in the middle of that, and again, it's right between two 13s. So the first quartile is third quartile is 13. Now, we started by sketching an axis, and we put 11 on the axis, and we put 13 on the axis, and we put 9 on the axis. Okay? Now, you have to be careful that these things are to scale. Some people had 13 way over here, so that from 11 to 13 the distance was bigger than from 9 to 11, but 11 is right halfway between 9 and 13. Now that's not always going to be the case in the distribution. It just turns out for this distribution, the first quartile, the median, and the third quartile are equally spaced. So you want to draw them as equally spaced. And if they aren't equally spaced, you want things on a consistent scale. You don't want some of your units bigger than others. Okay, so just to start the box plot, we did this. And then we know that we have to have the highest number and the lowest number. Okay, well, then what people did was they put the highest number here and they put the lowest number here. Equally spaced. Most people equally spaced the highest number and the lowest number with the numbers we already have on the picture. Well, the number here is 15, and the number here, lowest number, is clearly 6. Well, from 9 to 11 is 2, from 11 to 13 is 2, from 13 to 15 is 2, but from 6 to 9 is 3. So this interval needs to be bigger than any of these intervals. So you have to make sure your intervals are to scale. 6 doesn't go there. 7 goes here. If you want 6, you got to go over to here. Okay, on this picture. Now I have a 13 drawn here and X'd out. I was just illustrating that if somebody put 9 here, 11 here, and 13 over here, clearly there's something wrong. 13 really goes here, equally spaced with 9 and 11. Also, you can write your numbers. Your lowest, your first quartile, your median, your third quartile, and your highest. And you can look at what the spacings are. You just subtract each number from the one that follows it, and you get the spacings. From 6 to 9, you have 3 units. From 9 to 11, there are 2 units. From 11 to 13, there are 2 units. From 13 to 15, there are 2 units. So you get that spacing, and then you make sure that your points, you draw an axis and make sure your points are to scale. Okay, well, having done that, and I have a nice piece of blue chalk here. I don't know where the nice piece of blue chalk is, but I see a little nub here. Just to keep my picture consistent with this, show you how this one was constructed. Our box goes from the first quartile to the third quartile, as we say up here. So the first quartile is here, the third quartile is here, and the median is here, so here's our box. And if we do this right, I didn't do it very well here. This part of the box was a little smaller than this part, and then I tried to get it right here, and I made this one smaller, okay? This is a little better. The box is evenly divided because this distance is 2 and this distance is 2. Okay, so we have our first quartile, second quartile, median or second quartile, and third quartile. And then we've got a tail that goes out to our maximum and a tail that comes over to our minimum. This tail is shorter than this tail. This tail is the same length as this part of the box or this part of the box, but this tail is bigger than any of those intervals. So this gives us a picture. It says that, well, this interval really doesn't seem to be all that, or this data, at least in this sense, isn't completely symmetric. It's pretty close, but this tail is a little too big. So we know that a normal distribution is not going to give us a perfect model here, although it's going to be close. We still have a plausible normal distribution, but this data is not perfectly distributed, not perfectly normally distributed. We can comment on that. Okay, well, anyhow, here is our picture without the scaling. Okay, now I've really got, let's see, 2 of these, 1. This tail, I kind of exaggerated to show that it's longer. It should probably be about there. Okay. If you had a normal distribution, your tails would be equal. You'd have equal spacing between your first and second and third quartile. If you have something like this, it's really not a good candidate for normal. Your median is not halfway between your first and third quartile, and the two tails are very different. Okay, so that should give you a pretty good picture of the box plot. Now we had another exercise that we did with the normal distribution again, so we'll go over that.